Hey everybody, just wanted to record a quick video, a part 3 more or less of the dynamic queue workers because I just deployed everything to production today for the Laravel weekly release, the patch release that Laravel does on Tuesdays. So it was a good test of everything. Speaking of tests, that's also kind of the part I wanted to kind of recap on real quick for completeness. I apologize if there's a bit of a drone in the background. The AC is blaring today because it is hot again where I am in Louisville, Kentucky. So hopefully that'll kick off in a few minutes, but if you hear a little drone in the background, the vent is unfortunately right underneath my microphone. So, okay. Anyway, let's go take a peek at some of this stuff that I did off stream. So we kind of have all these jobs that we talked about before. The create worker, let's start in order here. We've got this create worker first, and then it ultimately will make the call to DigitalOcean to spin up a droplet from an image. I got all that mapped out and everything. And one of the biggest changes that I probably made in Create Worker was effectively this kind of worker name and then this track status. Some of the things we talked about on the stream were the potential for race conditions if multiple things spawned off this create worker, right? Because there are multiple pieces of the application that kind of listen for when workers should be increased. I've built in a few spots. So one's a listener for Horizon in general. If a wait time on a queue reaches a certain threshold, that's all configurable for Horizon. That's a Horizon event. So I listen for that long wait. That's one thing that can create a worker. And then anytime, of course, I detect that there's a new Laravel tag, that's something else that could create a worker. But I could also see eventually creating workers when new versions of a shift come out and maybe a certain threshold there is reached, a certain number of runs in several minutes, like a throttling, if you will. I could go ahead and preemptively spin up a worker just to be prepared for any additional load. So, but for now, the Horizon and the automation, the weekly automation, the tagging that happens in Laravel, they're really kind of enough. And that's when I know, again, Shift is going to be working overtime. So those are the only things I call create worker for the time being. But again, want to make sure that at least the writing of this data is atomic. There's nothing else that's going to be competing with this or doing shift worker names or anything going to be affecting these counts of the number of workers or anything like that at any point in time. So just a small tweak there. It's not necessarily tested per se, but I know it's kind of the right thing to do. So I just kind of wrap this up in here. Again, I test that the cache gets incremented and all sorts of things like that, but I don't necessarily test that this is done in kind of a locked way. I'm sure there's probably a way in which I could do that, but I'm not going to worry about it right now. So anyway, ultimately create worker spawns off a delayed call for check worker. It turned out that about 3 to 4 minutes was the sweet spot here, so I kind of bumped up that delay. I think in the streams before I did 2 minutes. It was right at 2 to 3 minutes, so I went ahead and made it 3 minutes just to avoid kind of a rerun of this check worker. And this is another thing. I created a new exception. So if I notice a lot of these this custom exception, if I notice a lot of these, I could bump up that timeout even further. So, but for now, kind of anecdotally on the 1 or 2 times where workers were created over the last few days, excuse me, I did notice that this was kicked every time the job was kind of spawned off. So I increased that timeout. We'll see next week. And again, this too has a track status, and the only thing it does here is just say that it is no longer spawning a new worker. A new worker has been spawned. So at this point, if this hasn't reduced the queue wait time and it requests for another worker to be created, then it's not going to get affected by that. And then finally, this create or check worker will delay a job itself for destroy worker. So long as everything happens correctly here, this status goes to active, it will go ahead and dispatch a delayed job to destroy this worker. And destroy worker is pretty straightforward. It does the same stuff. It makes the call so long as the call is successful, or if it's not successful in this case, it's going to fire off another one of those dynamic workers, and then it's going to track the status, again, all in an atomic lock to track worker, where I decrement the number of workers, I potentially remove the worker name that's been removed from the shift names. So just a little cleanup there. So each one of these jobs really does kind of the same thing in the end. We can go check out the test real fast. Let's just take a look at like check worker test, because again, they're pretty much all the same. So here I just have a real simple test where I kind of create kind of a naive object here for this check worker of the job. I don't dispatch it or anything like that. I just kind of create one, and I want to make sure, because it is important, I want to make sure that it has all these kind of dialed in back offs, right? I wouldn't want to ever go in and change these, like future me not paying attention and thinking, oh, yeah, I'll just bump the try. Why is this being retried? Like I forget in a couple years and I take it off. So things like that, even though this is a real simple, almost unit style test, it is worth it in this case because it's kind of a requirement. I've dialed these in, and I want to make sure that the back off's kind of, exponential, if you will. So it matters. And then otherwise than that, it's really just going through all the kind of logical paths in the code. So if we go look at check worker, the request could fail, the droplet could not be active yet, and then ultimately I would want to make sure that the job got dispatched. So again, all these jobs are pretty much the same. So in this case, if it's not yet active, I would go ahead and put the spawning new worker true to just kind of set up the environment. I fake out the queue, I prevent stray HTTP requests, and I ultimately call this and say that the status is still new in this case. And I would expect one of my dynamic workers and say worker is not yet active. So that's kind of what I'm expecting. And then I'm going to call subject. I'll talk about this here in a second. And then nothing got pushed on the queue, meaning none of those destroyed worker jobs were there. And I didn't remove that spawning new worker from the cache accidentally. So that's why that was kind of set up. So it's still true in this case. So let's look at the actual happy path, what I call. So same thing, we're going to spawn new worker. I'm going to set up test now. This is just one of those things where, like, whenever you're messing with date times or manipulating, adding 40 minutes from now to that delayed job, it just made it a little easier to control time. So I don't care what the time is, so I just kind of say now, but I keep track of that so I can use it for comparison down here later, right? So same thing, fake the queue, prevent stray requests. I'm actually going to call this. In this case, I'm going to get kind of a faked out response. I just took this from the documentation and tweaked some of the numbers. So here again, I just call subject and I assert that destroy worker was pushed. It was given the same ID. It was given the name that came from the payload, and its diff in minutes, its delay diff in minutes is 40. So it's a 40-minute delay. And then finally, that spawning new workers got set to false. So all these things that we want to happen. Real quick, let me talk about this call subject, because this is something that kind of got me for a second. Originally, I was doing, check worker dispatch here. And right away, you may or may not kind of see why this is a problem. It took me a few test runs to realize this is the problem, because all of my failure tests were passing, but none of my happy path tests were passing. And it was very strange because, like, the HTTP calls weren't being made. I threw in some poor man's debugging. Those weren't even showing up. I was throwing in some DDs, like nothing was happening. And then it dawned on me that I'm faking out the queue, and then I'm dispatching something to the queue. Another little nuance was that I was asserting nothing pushed, and that was failing. It was saying, oh, jobs were pushed. Well, of course a job was pushed because I just dispatched one after I faked the queue. So a little tricky in this case, because I am actually faking the queue and needing to see needing to kind of interact with a job, and this job interacts with another job, because of that queue fake, I actually need to kind of, and again, in a unit testy style way, I need to actually make a new instance of the worker and then forcibly call handle. Now that might be a little difficult if you're injecting things into jobs, because with jobs, Laravel kind of automatically handles kind of like any kind of parameter injection that you might have inside of your constructor or even inside of the handle method. So for those reasons, this could end up getting a little ugly, but fortunately for me, this checker worker was really straightforward. It was just an integer thing. I don't pass anything to handle. There's no kind of automatic resolution going on there. So I was able to just do this. But something to keep in mind, again, sometimes when you fake out these internal pieces like the HTTP layer, but you actually want to have a call really be sent, you're faking out the queue, but you want to dispatch a real job. You're faking out events, but you want to fire an event. Like, it can get a little tricky. So that was something I stumbled upon. Other than that, I can't really think of anything fancy that happened here. Again, I just kind of backfilled these tests. That led me to some of those locking issues. It led me to kind of wanting to have that dynamic exception up here. So things like that were really the only changes that I made from part 2 of the stream. So let me bring up DigitalOcean, and we'll see kind of from my activity where it made one, deleted one, made one. So let me fire that up real quick off stream. Okay, I brought this up in my other screen here, so hopefully there's no API keys or anything floating around, but here's Horizon for Shift. So when I started recording this video just 10 minutes ago or so, there were actually 6 processes total. So there was an additional worker with an additional 3 processes. So 3 is kind of my baseline no matter what. And if we just kind of go look at some of the completed jobs here, we'll actually see that destroy worker got fired off just a little bit ago. And if I jump over to DigitalOcean's activity, we're not going to be able to see that droplet anymore. But we can see here that this was me kind of toying around last night. But here, just an hour ago, when Laravel had tagged today's release 9/26, and the queue kind of built up with a long wait time, once Shift started that an hour ago, it added this droplet. That droplet was ultimately created, meaning it became active. And then if we look, 43 minutes after that, remember we have a 40-minute delay between the destroy worker and, the check worker and destroy worker gets put on the queue with a 40-minute delay. So look at that, 43 minutes later, basically, 42 if we kind of hover over the times, it was removed, and therefore this queue went back down to 3 processes. So we can see that this was completely automated based on this activity. Now, of course, I was watching this like a hawk today because, again, I wanted to make sure I didn't spin up like 20 new workers or whatever. But we can see that actually just spinning up 1 additional worker, in this case today for the stuff that was on the queue, was enough, and within 1 hour it was removed. So I talked about this in part 1, the economics of this. It's probably not, it's not really required. This is kind of fluff. These boxes are 10, 15, 20 bucks a month. But here's the thing. Laravel only tags something once a week. This particular server cost 8 cents an hour. It's a huge server. Still, it has plenty of specs, more than my server that I had dedicated for the entire month. This thing spun up in an hour, and less than an hour had been removed. So I paid 8 cents for this. I'm going to pay that 4 weeks for the month. So potentially I'm going to pay under 50 cents and get more computing power and get these things out faster than if I had a dedicated worker that I paid for on a monthly basis. So that's a better UX that cost me less. It's a better experience for subscribers to Shift or people running shifts, again, if there is a larger workload. So while the economics for saving $15 a month are a bit laughable for some people, this was something fun to work on, and it actually is an impressive savings when you think about the percentages. I reduced something that was $15 a month and brought it to probably under $1, even if these ran for multiple hours at a time, or I ran 2 or 3 workers at a time. So I think that's pretty cool. Hopefully you enjoyed this little mini series working on these. Again, I just wanted to have a follow-up thing where you kind of got a quick look at the tests, but we also got to see it in action, which I thought was pretty exciting. So I'll probably do a follow-up blog post that I'll share on Twitter, so if you want to see more of the numbers, if you're interested in that, if you're interested in the backstory, definitely check that out later in the week on Twitter. Otherwise, again, hope you enjoyed part 1, 2, and 3 of this little series here. So thanks, and see you all in my next live stream.